And so distance formula, I think I've had this conversation with y'all too, that the distance formula is really just the Pythagorean theorem. So if you think about, if I'm trying to find the distance from here to here, then I'm wanting, what I'm really doing with this formula is figuring out how long is this side and how long is this side. So that's this squared plus this squared is going to give me my distance squared. And so then I just take the square root. So this distance formula is really a fancy way of using the Pythagorean theorem. Okay, so if you're writing things down for notes purposes, this is all you need. You just need to know the formula. All right, so to find the distance. So just like with slope, x1 and y1 are kind of irrelevant as long as you keep things kind of together. For distance, it's really less important because you're subtracting and then squaring, so it's not, the sign isn't that big of a deal. So you just need to make sure that you get the difference of the x's, the difference of the y's, square them, add them, take the square root. So I honestly don't even know when I write these down half the time if I'm following the formula. I'm just doing the math that I know is right. So we're going to take the x's, -5, and subtract -2 and square it, plus the y subtracted, so 1 minus 5, and square that. So we get -5 plus 2 is -3. And we get, what is that, -4. All right, so if you square a 3, you get 9. If you square a 4, you get 16. If you add those together, you get 25. If I take the square root of that, I get 5. So ultimately, the distance is 5. Now, do I need to see every one of those steps on your paper? Absolutely not. I know you can do half of that in your head, and I know you have a calculator. Let me caution you with the calculator, though, if you don't do parentheses, then it's going to square a negative and give you a negative. So parentheses are important. Make sure that you're handling those if you're just trying to jump to your calculator from like here or here. Make sure you put the parentheses where they need to be. Okay, so number 2. Let's see. We want, so the square root of, we're going to do 4 minus -6 squared plus -1 minus 3 squared. So let's see what we get. 6, 7, 8, 9, 10. Because minus a negative makes you add. And then what is that, -4? I don't know if y'all heard that. One of my neighbors just shot. I wonder if he got a turkey or a snake, one or the other. Okay, so we got 116, right? 10 squared is 100, -4 squared is 16. So yeah, 116. All right, so at this point, if that will simplify, you can simplify it. But for the purposes of what we're going to be doing, we're going to be using distance to figure out like how to graph things. So I don't know why my finger itches so bad, y'all. Sorry if that's annoying you. It's annoying me. So we're just going to take our calculator and find the square root of 116 is 10.77. Pay attention to your directions. It'll tell you what to round to if it wants rounding. So we're at about 10.77. Okay, so that's the distance formula. You may get a pretty answer. You may get a yucky answer. It's okay either way. Okay, so our next one is midpoint. This is what I want. Okay, so for the midpoint formula, you are averaging. You're finding the middle of two things. It's really just an average. Add them together, divide by 2. So if I know this endpoint and this endpoint, I'm trying to find the middle. So I add my x's, divide by 2, add my y's, divide by 2, and I'm done. Does the order matter? Doesn't matter what order these are in as long as they're both x's. But it is important that this is x and this is y because it's an ordered pair. All right, so here are a couple. If I want the midpoint between these, we're going to do -3 minus 6 plus 6. Sorry, add them together, divide by 2. -4 plus -8 divide by 2. All right, so we get 3 over 2. And we get -12 over 2. So 3/2 or 1.5. I don't care what you call it. 3/2 or 1.5. Whatever makes you happy. And then this would be -6. Now, usually I like fractions, but again, my goal in this is to be able to, I don't know why when I hit undo so much stuff goes away. It drives me crazy. Okay, the goal is I may want to have to plot this point. So it's easier for me to find it, to plot it if it's 1.5 than if it's 3/2. But again, whatever makes you happy, I'll take either. Okay, so number 4. We are going to take the x's and add them. And I know you're thinking, why are we throwing radicals in here? Because they do. They come into play when you're doing circles. Not all the time, but sometimes. Okay, but they're keeping it friendly in the book. So these match, right? Root 3. So it's like I have 7 of these plus 3 more of these. So I have 10 of them. So I have 10 root 3 over 2. And then here I just have -10 over 2. All right, so we can divide here. You cannot divide under this, but since these are being multiplied, you can divide the 10 and the 2 and just have 5 root 3. And then this divides and is -5. So that would be the midpoint of those 2 points. So for this, again, for now, we're going to leave it because it looks better. But if you were actually going to have to use it, you'd have to type that in your calculator and get a decimal so you knew kind of where it was. Sorry, y'all, my calculator just randomly flashed. That was what that face was about. I know I make them all the time. But that one had a reason. Anyway, okay. So that was distance and midpoint. It was kind of fast, but those are old formulas that you've used a lot. So hopefully they made sense. Remember, you can always pause me, rewind me, listen to it again, whatever. Okay. So for a circle, we have a couple of options. So you have dealt with these. We graphed some circles with the inequalities in that last section. And they were the nice basic ones centered at the origin where you had the radius. So it was the square root of this answer number. So we're going to jump over to my radius is not at 0, 0. So do you see how the radius moved to +2, -5? Well, that just means those numbers go in there with the x and the y. So this standard form of a circle, it's handing you the center and the radius on a platter. So if it's in standard form, circles are really easy to graph. The problem is going to be when they give you general form and you have to turn it into standard form by completing the square. Those are the ones y'all are not going to like. But you should be okay with these guys. All right, so just like with everything else you've ever done in math, I don't know that if you've picked up on this or not, but basically, since you've been in high school, anytime you pull something out of parentheses to use it to graph, the sign changes. So this says -2, but we plotted at a +2. This says +5, we plotted at a -5. That's because the formula started out with negatives. So this is minus a +2, and this is minus a -5. That's how it became plus. Okay, so let's work on some examples. The first thing they want us to do is they're giving us the info. You write the equation. So again, we're working off of this as our standard form. All right, so this is H, this is K, this is R. So we're just going to put things in the right place. So we have x minus a +3 squared plus y minus a -2, so that makes it a plus, is equal to 7 squared, so 49. All right, so this one, same concept. You have x minus a -1, so that makes it +1, squared, plus y minus a +5 squared equals the square root of 6 squared. Remember that square root squared is going to cancel each other out. So that's just 6. Okay. That's that. So those last 3 topics that we did, there should be at least one of each of those on your test when you take it. Make sure you're good with those. All right, so now let's talk about, can we graph? All right, so if they give you standard form, life is easy. You can tell me the center, you can tell me the radius, you can graph real easy, and then domain and range is a piece of cake once you've graphed it. All right, so we need to know what the center is. So the center is opposite of the number with the x, opposite of the number with the y. The radius is the square root of the answer number. All right, so to graph, you find your center, mark that point so you know where it's at, and then you're going to go out in both directions and up and down the radius. So 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Y'all, if I plot something wrong, I apologize. I'm struggling to see. I think that's 4. All right, then we are going to do our absolute best at drawing something that resembles a circle more than it does an egg. I started out really great, and then it got really bad. Okay, so am I looking for perfection when you graph? No. If you don't have graph paper, can you still graph? Yes. Draw an XY coordinate plane. Put you some tick marks on there. Do your best. Do I need your circles to be a little better than mine? Probably yes, because you are on paper and I am on this stupid program that looks too fat. Y'all, I'm going to try one more time and then I'm just done. It looks like it looks. There. I need you to aim for something about that good. I'm not looking for perfection. If you have like, I don't know, some quarters or bottle caps or whatever, you can try to use those to trace, but it's going to be hard to get your radius right, so whatever. Okay, so looking at the picture, domain and range. Remember that domain is left to right. So far left to far right. So if you look at the far left of our circle, it is at, what is that, -7? And it goes over here to 1. Now, keep in mind that I went a little past because, you know, I can't draw, but whatever. And we use brackets because those values are included. There's points there. All right, so then range is top to bottom. So the bottom of our picture is at -3, and the top is at 5. Yeah. So we're going to say go from -3 to 5. And that's all there is to it. All right, so next problem. So x doesn't have parentheses around it. So guess what that means? When you do your center, the x coordinate is 0. The y coordinate is -5. All right, range, not range, sweet mercy. Radius is 3, the square root of 9. All right, so I think I'm going to have to move all of this up so we can see past my face. All right, so 0, -5 is here. Then we go out 3, up 3, out 3, down 3. And we do the best we can to draw something that resembles a circle. All right, so domain and range. Always brackets, always from a number to a number for a circle. All right, so left to right, we go from -3 to 3. Bottom to top, we go from 1, 2, 3, 4, 5, 6, 7, 8, -8 to -2. Okay, so there we go. Let's see. All right, 2 to graph that are not in standard form. All right, so if you're not in standard form, you're going to complete the square so that we can have standard form. Then give the center and radius and graph. And these directions don't ask you for the domain and range. You can do it if you want more practice, but you don't have to. I tried to mimic the directions for the problems in your book. All right, so complete the square. That's a skill that you have. We've done it in this class way back in, I forget what chapter, whichever one was quadratics. It wasn't quadratics. You were graphing like quadratics, polynomials, yada yada. I think it was chapter 3. Anyway, so to complete the square, you're going to take an x squared plus an x and then give it a constant that forces it to factor to parentheses squared. So that's kind of the idea. So here's what we're going to do. We're going to put our x's together with a plus blank, and then our y's together with a plus blank. Move the constant to the other side, and then you need plus blanks that match the ones for the other side. Okay, so to recap that, because that was a lot of words, I need my x's together because my goal is to create a trinomial that factors to the same thing squared. I need my y's together for the same purpose, because I'm trying to create a trinomial that factors to parentheses squared. We move the constant to the other side to get it out of our way. And then if I add something to one side of the equation, I have to add it to the other. So that's why I need counteracting blanks on the other side. Okay, so here we go. For the x's, remember the process of completing the square is you take half of the linear term, the number with the x, and it goes in parentheses for the factored form. I square that number and put it in the blank. So half of 6 is 3. 3 squared is 9. I have completed the square successfully. Half of this number goes in my factored form. Square that guy. He goes in the blank. So the magic number I needed to add was 9 to make this a perfect square trinomial so that it factors to x plus 3, x plus 3. Okay, so that means a 9 goes over here. All right, so for the y's, half of 2 is 1. 1 squared is 1. So a 1 goes over here. All right, so this number, you just add all these up. So negative 6 plus 9 is 3, plus 1 is 4. Now I have the standard form and I can graph. Before we do that, let me back up for a second and say, one of the questions on your test, maybe more than one, is can you look at the equation and tell me, is it going to be a circle, an ellipse, a parabola, a hyperbola? So there's going to be easy ways to identify each. So first of all, a circle is going to have an x squared and a y squared that are being added. So it should have a positive x squared and a positive y squared with no coefficients or matching coefficients. So if this was a 2 and a 2, or an 18 and an 18, then you know it's a circle because you can divide those off and have ones. Okay, so to recognize a circle when it's in this general form, I think I just said standard, sorry. When you're in general form, to recognize a circle, you have an x squared and a y squared that are both positive with the same coefficients. That's how you know it's a circle. All right. If you're looking at standard form, you know it's a circle because there's no coefficient of your parentheses and it's equal to something other than a 1, which will make sense when we talk about ellipses on Monday. Okay. So looking at what we have now, we have a center at negative 3, negative 1, and a radius of the square root of 4, so 2. All right, so negative 3, negative 1. And then out in all directions, 2 units. And then we do our best. The smaller they are, nope, I shouldn't have said that because it's not true, apparently. The better I am. That's what I was going to say. The smaller they are, the better I am at drawing them. But that's a big fat no because that's pretty ugly too. Okay. All right, so let's try one more. Here we go. We have x's together with a plus blank so that we can factor. Y's together with a plus blank so that we can factor. This negative 10 goes to the other side. You add it over there, so it's a plus 10. And you need a plus blank for what you added on the x's and a plus blank for what you added on the y's. Okay. So for our x's, half of 8 is 4. It's a positive 8. So half of positive 8 is positive 4. Positive 4 squared is 16. All right, here you have a negative 12. Half of negative 12 is negative 6. Negative 6 squared is positive 36. I forgot to put my numbers over here. All right, so what is that? Ooh, that's a big old number. 26 plus 36 is 62. Yeah. All right, so we have a center at negative 4, positive 6, and a radius at the square root of 62. All right, our goal is to graph that, be able to go out to that distance. So I'm going to go ahead and call that 7.87. I just took the square root with my calculator. I got 7.87. Okay, so here we go. Negative 4 and 6 is here. I'm going to go off of my graph in all directions. Okay. 1, 2, 3, 4, 5, 6, 7, almost 8. All right, so again, am I looking for some perfection on plotting 7.87 away? No, I'm not. 1, 2, 3, 4, 5, 6, 7, almost 8. 1, 2, 3, 4, 5, 6, 7, almost 8. 1, 2, 3, 4, 5, 6, 7. I might need to really be a little higher than that, but we'll call it good. All right, so we are going to draw a very scary looking circle. Close enough. All right, so there we go. All right, so I don't think there are any in this section, but if I gave you the circle, could you figure out how to write the equation just by looking at the picture? Well, let's go back to the one where you can like measure things well. We'll do this one. So if I was looking at this picture, if I could find the center, so negative 3, 1, then I could plug those back in and I can count the radius and then I could plug that back in. So if you were given the graph of a circle, all you'd have to do is look at it and label the center and the radius, and then it would be problems like these guys where you can plug them in. Okay, y'all let me know if you have questions. Attendance purposes question. I really don't know. I hadn't thought that far this morning. So how about you tell me this? How do I recognize that I have a circle? Because that's something that we're not going to do a lot with that I said. So back on this slide, so when I started number 9, so rewind until I started number 9, and I told you how you can look at the general form and decide how it's a circle. If I'm looking at the general form of a conic section, how do I know it's a circle? It had to do with these two terms. All right, y'all, good luck. Make sure that you let me know if you have questions. I think this is a fairly easy section, but it's also something that you haven't done since geometry if you did it then. So let me know if you have some questions.